Hello and welcome to Lesson 12 of National 5 Computing Science Database Design and Development. Today we're going to finish off these two queries. This is selecting data in a query from more than one table, so two tables in this case. In the previous video we selected the dog's name and the walker's name from the dog and walker table, and we made sure that it was the correct walker who walked that dog by joining like this, and we made sure the breed was Chihuahua. We didn't save this though, so let's save it. And let's close it. The next query is to show the names of all dog walkers who walk Chihuahuas or Rottweilers. Again, this is almost identical to this. We just need to add this extra little piece on the end. So let's grab that other query. Let's open it in Design View. Let's copy it, Control C, and let's create a new query. And we'll go to SQL View and we'll paste, Control V. We need to change this ever so slightly by adding, surely it's just or breed equals Rottweiler. Surely. What do you think? I'll give you 3 seconds to say yes or no in your head. Well, let's run it and see. I think it's not going to work. And you can see we've got another problem. We've got 12,000. No, is that 12,000? Yeah, 12,022 results. Again, we know that is wrong because there are only 650 dogs. So how would it be possible to have that many dogs who are Chihuahuas and Rottweilers, walked by these people? So what is the problem? Well, whenever you introduce an or, you're opening it up to all sorts of complications. You basically need to ensure that it is limited or restricted to what it is you're choosing between. An or is always a choice between one or the other thing type scenario. But if you read this query, what it's saying is, where the dog's walker ID is equal to the walker's walker ID, and the breed is Chihuahua, so this is like one thing, or breed equals Rottweiler. And then, so this is like a separate thing, almost. So we're not saying where the join is correct and the breed is either Chihuahua or Rottweiler. Like SQL, like computers can't decipher what we think, what we intend. We have to be more explicit. It's almost, in a way, a bit like BODMAS. We have to be explicit. So we basically, all we need to do is put brackets around this or. So what we're saying now is the dog walker ID must be equal to the walker's walker ID, and the breed should be one of these two. That's basically what we're saying. So if we run this, now we've got a much more, come on, show me. There we go. A much more, there we go. We've got a much more realistic number. And we could double check this by going to the different tables and identifying the walker and the dog and then checking the breed. What I would do in this scenario, let's just include the breed. And then this will let us know that it's only Rottweilers and Chihuahuas. Perfect. But obviously when it comes to handing it in, just get rid of that. That was just for testing purposes. Let's save this one. Let's give us a bit more room so we can see the query names. Beautiful. And the final query, and this will be the last video on select queries. Show the names of all dog walkers who walk Yorkshire Terriers that are older than 10 years old. Let's start from scratch for this one, instead of copying and pasting. So we'll create a query, and we'll make sure it's SQL View. And what are we selecting? The names of all dog walkers. In fact, I've just noticed that my previous two queries were wrong, technically, because it didn't ask for the names of dogs. Never mind. So the dog walkers, they have forenames and surnames. Oops. We only get this information from the walker table. But you'll see that we actually do need both tables, and I'll show you why in a minute. But what's the where clause? It's where the breed is Yorkshire Terrier and where the dog's age is older than 10 years old. So where breed is equal to Yorkshire Terrier and the age is it older than 10. So this is the query. But as I said, breed, where does that come from? If we go to database tools, relationships, breed is here. And likewise, age, this comes from the dog table, but we didn't say we needed the dog table, but we do. So let's include it, dog. Even though we're not displaying anything from the dog table, we're using it in our criteria. Now, again, this is going to be wrong. It's going to give us millions of results, or 1,600 results, which is clearly wrong because there aren't even that many dogs. So how do we fix this query? It's the join. I just clicked here. The join between these two tables, the link where the foreign key is equal to the primary key. So that's what we need to include. So we can include that at the end. And walker.walker_id equals dog.walker_id. Oh, why can't I type? There we go. And this should fix it. Wow, only 4 people. 4 people walk ancient Yorkshire Terriers. That seems reasonable, actually. There is a way we could double check this, because I could go through the tables again, but let's double check it by including the breed and the age of these dogs. Yes, all of these people walk Yorkshire Terriers that are older than 10. Isn't this amazing? But once again, you would make sure you delete that from the final query when it's time to hand it in. And there you have it. We've done a bunch of select queries, 10 select queries, and this should give you the brief introduction as to how to create all the types of select queries that you require. In the next one, we're going to look at insert, delete, and update.